This video is going to be about the distance formula. And what I want to do is start with a problem and then figure out the distance, what the distance formula is from the way we work the problem. So let's say we're given these 2 points as if they're points on a graph. And we're told to find the distance from one point to the other. So we could draw a rough graph. And we could plot the 2 points. So I've got a -1, comma -2. So -1, -2. And I've got the other point is 3, comma 5. So here's my 3, and I'll go up to 5. And that will be 3, comma 5. And I want to find the distance between these 2 points. Well, the distance between those points would be the length. If I connected the points with a line, it would be the length of that line. What we're going to do is we're going to think of this line as the hypotenuse of a triangle, and then we're going to use the Pythagorean theorem to find its length. So if this is the hypotenuse, the triangle has 2 legs. One leg would come down like this, and one leg would go across like this, and I'd have a right angle over here. So here I'd have I could think of this as side A, or leg A, and leg B, and the hypotenuse is side C. Okay? So let's see. I need to find the distance. I need to find the length of A. Well, A is going to be the distance from this x value, the -1, to the -3. In other words, I'm going over here from -1, which is where I am here, to -3. And I could find that distance by subtracting one of the x values from the other x value. Let's make sure we know these are x values. So if I subtract one from the other, I'll find the distance is 4. In other words, 3 minus -1 is 4. So A is 4. And in the same way, I can find this B leg, or the y distance, by finding where I am here on the y-axis. Well, here I'm down at -2. I'm going up to +5. So subtracting one number from the other, let's take -2 minus 5. Well, -2 minus 5 is -7. It doesn't matter that it's negative, because if I'm thinking of a distance, there's no such thing as a negative distance. So the distance is actually 7. So now I've got these 2 legs. Okay, so the quadratic formula, the Pythagorean formula, says c squared equals a squared plus b squared, or c equals the square root of a squared plus b squared. And now I'll just plug in my a and my b. So a is 4, so 4 squared plus 7 squared, and running through the math part of it, 4 squared is 16, plus 7 squared is 49, and 16 plus 49 is 65, so I get the square root of 65, and 65 is not a perfect square, and there are no factors of 65 which are perfect squares, so this is going to be my answer. Now, what I want to do is take what we just did and look at this in a more general way, so we can actually have a formula for working these problems in general, and that's going to be the distance formula. So starting again, remember we thought of the first values that we have in these 2 sets of ordered pairs are x values. So I'm going to call them x sub 1 and x sub 2. And the second values are y values, so I'll call them y sub 1 and y sub 2. And to find the lengths of the 2 legs, what we did was we subtracted one x from the other x, and then we subtracted one y from the other y to find the length of the y side, the b side in this case. Okay, so let's take this and erase it from here and plug in just x's and y's. So in other words, now I'm going to have c equals let's see, A was the difference from x sub 1 to x sub 2. So if I subtract one of these from the other ones, I'll get my length over here. So this is going to be x sub 1, actually I think most books use x sub 2 first, minus x sub 1. It doesn't matter what order you do them in. And we're going to square that. So this is what I was calling leg A, and that's squared. And then I want leg B. So leg B is going to be y sub 2 minus y sub 1, and that's squared. And then all I would have to do, let's do this problem again, just from here without even looking at the graph. So C equals the square root of x sub 2, that's going to be 3, minus negative 1, which is x sub 1, negative 1, squared, plus, I want the other length, that's going to be y sub 2, 5, minus negative 2. Got to be careful with your signs here. And that's going to be squared. Okay, and now we can just take this all and simplify it. So I'm going to get C equals the square root of 3 minus negative 4, negative 1 is 4, squared, plus 5 minus negative 2 is 7 squared. I don't need that much. So C equals the square root of 4 squared is 16, plus 7 squared is 49. 16 plus 49 is 65. The square root is 65. Okay, so let's just review this quickly and write the formula one more time to make sure that we're good at it. Okay, so the formula that you're going to want is going to be, you could call it C, or you could call it D for distance, whatever that length is that you're looking for, is going to be equal to the square root of x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1 squared. And all you have to do is remember that this is the length of one of the legs, and this is the length of the other leg, and you're just taking your two legs and squaring them and putting them under a radical sign, and you're finding out what the hypotenuse is. And then all you have to do when you're given 2 points, in this case we had negative 1 comma negative 2, and what was it, 3 comma 5, is look at your first 2 points, your x values, and plug them in over here. It doesn't matter which one you call x sub 2 and which one you call x sub 1. And then look at your y values, that's the second part of your ordered pair, and plug them in for y sub 2 and y sub 1. And then combine them, square them, add the two things to the two squares together, take the square root of it, and you'll have your answer. Okay, so this formula looks complicated. If you understand it, it will begin to make sense, and you won't even have to memorize it. You can, well, maybe you should memorize it, but if you forget it, you can just recreate it on your own by thinking of the logic behind it. Okay, so that's the distance formula. Take care. See you next time.